All right, this is chapter 6, section 4, using inverse functions. Vocabulary, obviously, first is an inverse function. It's a relationship that interchanges the inputs and outputs of original values. Basically, what you're looking at is the fact that you're going to have some relations. A relation would be like 2, 3, 3, 4, and so on. And so what you're doing is you are interchanging inputs and outputs. So 2 is the input, 3 is the output. If 3 is the input and 4 is the output, you're interchanging them. So instead of 2, 3, the inverse is 3, 2. Instead of 3, 4, the inverse is 4, 3. That's how inverse relations work. Inverse functions, the original relation and its inverse function, whenever both relations are functions. Basically, what this is talking about is the fact that you can have one function and you can do the inverse of it. So an inverse function is a function if and only if the original, the original and inverse, are functions. And that's denoted by saying here's f of x, and the inverse is f to the negative 1 of x. All right, that's how this works. All right, now there are some 3 simple steps on how you determine whether something is a function or not. First of all, step 1, switch, or yeah, we'll use the word switch. Switch f of x with y. So basically your equation, if you have f of x equals something, it's going to become y equals. Number 2, you're going to make another switch. You're going to switch the x and y variables around. And number 3, you're going to solve for the variable. You may want to write this down on the side of your note-taking guides just to keep it, remember that these are the 3 steps you need to do. Because now we'll look at those 3 steps and actually look at a problem. Since we already have y, step 1 was to switch f of x with y. We already have y, so we don't have to do step 1. Step 2, switch x and y variables. So switch x and y variable, that means y becomes x and x becomes y. Basically, look at our definition for the inverse relation. All we did was we switched our x and our y around. Once you do that, you solve for the variable. So now you're solving for y. We solve for y by adding 4 to each side. So now you have x plus 4 equals 7y. Now it says solve for y, and this is the inverse relation. So basically, you now divide by 7. So divide by 7, divide by 7. Our new function, our inverse function is y equals x plus 4 divided by 7. That's the inverse. All right, we'll do some more of these in a little bit. Now, inverse functions, functions f and g, this is a part of your note-taking guides. They're inverses if when you do a composite. 6.3 was about finding composites, f of g of x, g of f of x. When you find the inverse of them, if you do the composite, you'll end up with just x as your answer. So g of x, f of g of x is x. G of f of x ends up being x. Right? And the function is denoted by f to the negative 1. We've already talked about that. So let's do the composite here. This is the original, this is the inverse. We need to show that show that the composite is equal to x. So f of f inverse x. Well, f inverse x is right here, so we switched it. They did it for us. Now you take this piece of information and you plug it in for this x right here. So let's do that. 7 times x. All right, x is now being replaced with 1/7 x plus 4/7. Now let's distribute. Distribute the 1/7 in. 1/7, 7 times 1/7 is 1. 7 times 4/7 is plus 4. I forgot to add in here the fact that I did the 7x right here. I forgot to put the -4 here, which means I put a -4 there, which means my result is just x, which is what we were hoping for. So that's half of it. Now we have to do the other half. We have to find the f inverse of f of x. So f inverse of 7x minus 4. I just took this and plugged it in. So now we look at the inverse function and we plug 7x in for it. So let's take a look. Here's the inverse function. Here's an x. So we change that x with 7x plus, or 7x minus 4. And then don't forget what's left over, the adding 4/7. So distribute again. 1/7 of 7. 1/7 of -4. Plus 4/7. These cancel, equals x. Since both functions are equal to x, you've now shown that they are inverses. All right, so let's take a look at this checkpoint right here. It says to find the inverse of the function, then to verify your results and the original function are inverses. So first step was to replace f of x with y. So now we have y equals 3x plus 5. Second step said to switch x and the y around. The last step says to solve for the variable. So we're solving for y. We -5 both sides. We divide by 3. And now you have that y equals x minus 5 divided by 3. That is the how you find the inverse. Now, as far as verifying goes, to verify you have to do, and the notation, of course, has the -1 of x equals this. So now, to verify, this right here is good enough. But if you wanted to verify, if it says to verify, go ahead and you have to do the composite f of the inverse of x, and then you have to do f inverse of f of x. And when you do this, you're going to end up you're going to do all the work, and it's going to be that x should equal x, should equal x. That is the verification for that these are inverses. So f of x negative 3x plus 5, f -1 of x, x minus 5. All right. So guided practice. Let's take a look now. Guided practice number 1 from 6.4 says to look at number 1. We'll probably just do 2 of these. Number 1 is to look at f of x is x plus 4. So step 1, replace f of x with y. Step 2, switch the x and the y around. Now solve for y. And then go ahead and put the f of x back in there. So f of -1, or f inverse of x is equivalent to x minus 4. So I'm going to walk through the verification process for this just to make so you can see it. Let's start by doing f of x. Let's do the inverse f of negative 1 of f of x. F of x, the original equation, was x plus 4. So now every place there's an x in the inverse, you replace it with x plus 4. So here's the inverse. Replace that x with x plus 4. So now you have x plus 4 replacing the x. You're subtracting 4. X plus 4 minus 4. The plus 4 minus 4 becomes 0. So you end up with just x. So the inverse of f of x equals x. Do the reverse. Do this. So now f inverse of x, we found it and we said it was x minus 4. We now are going to replace this x with that. So x is now x minus 4 plus 4. Minus 4 plus 4 is 0. So now you have that the f of f inverse of x is x, which now verifies your work. So go ahead and try the other two guided practices. They should help you on the homework. All right. Finding the inverse of a power function. It's the exact same steps. Replace f of x with y. Switch x and y. Solve for the variable. So, write the original equation. Replace f of x with y. Switch x and y. So y becomes x, 4y squared. Divide each side by 4. So now you have x over 4 equals y squared. Take the square root of each side. And so basically what you end up with is y equals the square root of x over the square root of 4. And the square root of 4, everyone, you should remember, is just 2. All right. Now some people had a question about this right here. It's telling you to find the inverse during the interval or during the time when x is less than or equal to 0. When x is less than or equal to 0, all right. So when x is less than or equal to 0 here, let's take a look at this. This is example 3. It's basically telling you which one to graph. Basically what I'm dealing with here is when you introduce a square root, you should do plus or minus the square root x over. This should be y equals plus or minus the square root of x over 2. But when you're graphing it, if it's saying only graph or find only the inverse for when it's less than 0, well, less than 0 means negative. So if x is less than 0, if x is less than 0, that means we're looking for the negative part. So we're actually only looking for the graph that looks something like this. That's how this is set up. That is the equation for this. This is the inverse. The original equation then would look like that. This is the original. So this was f inverse of x. This is f of x. All right. This takes us to our next next part of the note-taking guides, the horizontal line test. You hopefully should remember that something called a vertical line test that told you whether a function was an inverse or not. The horizontal line test will tell you whether the inverse is a function or not. So the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than 1 over 2. So if x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is more than 1 over 2. If x is less than 0, then f is than ones. All right. So if this is these are originals. This graph, horizontal line test, those aren't very good horizontal lines, but there's no place where that would cross twice. So this is, the inverse is a function. This, see all the places it crosses twice? That causes problems. You can think of this with a lot of different, oops, okay, so let me look here. Let me draw a graph. So if you have something that looks like this, okay, is the function f of x is a function because it passes the vertical line test, but f negative 1 of x is not a function because right about here, 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 it crosses that line more than once. That is why this graph is not a function. So, example 4, find the inverse of a cubic function. Consider the function here. Determine whether the inverse of f is a function. Then find the inverse. So for example 4, what you're doing is you're going to graph this. And feel free to graph it in your calculator. If you don't want to graph it in your calculator, you need to use a table of values. All right. So if you wanted to use a table of values, you'd use x, y. And I would say to be safe for this, since it's not a straight line, maybe do 3, 1, 0. I'll make those negative. 1, 3. You plug those in, and then see how it goes from there. I can do 0 for you quickly. 0 cubed is 0 times 1/4 is 0 plus 2. So 0, 3. So it goes through the axis right here. It looks like when you graph this in a graphing calculator, it looks like it kind of goes through some of these points here. So your graph should look something like that. That's what your graph should look like in the calculator. Now, in graphing this, you'll see, let's look, are there any places, horizontal line test, horizontal line test. Is there any place we can draw a horizontal line that crosses that graph more than once? Can you? Right, you can't. So this inverse should be a function. Now, that being said, let's actually take a look at finding the inverse of it. All right? So help me find the inverse. First step, exchange f of x with y. Now switch the variables. So now y becomes x becomes y. Now solve. So minus 3. Multiply by the reciprocal. 4x minus 12, because we're distributing the 4, y cubed. And then you cube root everything over there. So your inverse is the cube root 4x minus 12. And both the original and the inverse are functions, therefore this is considered a inverse function. Alright, this is going to be a little bit of a shorter video. We're going to do these checkpoints and a couple guided practices. So, find the inverse of the function. Step 1, change f of x with y. Step 2, switch the x and the y around. Now, step 3, solve for y. So minus 1, x minus 1 equals 2y to the 4th. get rid of this multiplication. So now we've got x minus 1 over 2 equals y to the fourth. And now fourth root. Fourth root. So y equals fourth root x minus 1 over 2. That is the inverse. Please remember, though, you really should take into consideration which one they're talking about, the plus or the minus. Since it's x greater than or equal to 0, you're going to show only the plus. It should be plus or minus, but you're only showing the plus. All right, here, g of x. Oh, no, it's a g instead of an f. It doesn't matter. You're going to replace the g of x with y. You're going to get rid of this, switch the variables. Now solve for y. Multiply by the reciprocal. So 32x is y to the fifth. Now take the fifth root. So your new function is, and since this is an odd root, you do not have to do plus or minus, but it's the fifth root of 32x. Now, I'm happy with that, but please notice the fifth root of 32 is 2. So the best answer is 2 fifth root of x. All right. Now, if ever you're being asked what is the domain or range, remember, odd roots, all reals, no problem. An even root, this inside has to be greater than or equal to 0. That's how you should set it up. All right, let's look at the guided practice, and then I think we'll be done. Guided practice 5-7. Let's do, I'll do like a couple here each. F of x. Let's do number 5. F of x is x to the sixth. Now it says that it has to be greater than or equal to 0. That means we're looking for the positive one only. Well, replace f of x with y. Switch the variables. And solve for x. Sixth root. Y equals the positive sixth root of x. So that's how that domain is set up. Remember, if it's asking for domain, the x value has to be greater than or equal to 0. All right, let's look at number 9. Number 9 is f of x equals 2x to the fifth plus 3. 2x to the fifth plus 3. Step 1, replace f of x with y. Step 2, change the x's and the y's around. And then solve. So minus 3 both sides. X minus 3 is 2y to the fifth. Divide by 2. X minus 3 over 2 is equal to y to the fifth. From here, we take the fifth root, and you end up with y equals the fifth root of x minus 3 over 2. All right, so all of these should help you with all of your homework. You should be able to do the rest of the guided practice, and then here's your homework.